That we are here, I'll be showing you how to tune the elevator mechanism. If you followed the tutorial exactly, you should have already ended up here. But if you need to refer back to it, just pause this video and go back. For tuning, we are going to be following the guide on Montique and also which was derived from the technique developed by, I forgot the name, but it's from Super Nerds in their 2025 build thread. I kind of combined some of the WPI Lib recommendations with theirs to create this method. So the first thing we're going to do is we are going to set the set point to something unreasonable. So like this set point is in meters. You can also visualize it on here. If we set it to like 3, then give me a second. Then it should be updating here, but I guess not. But basically, we can now update kg. So kg is the value that that updates whenever. Sorry about that. Kg is the value that is updating. There we go. I just had it on the wrong mechanism. Kg is the value that is like Ks, so it's the static amount of static voltage needed to keep the mechanism in place, because obviously gravity is acting on the mechanism, so you need a little bit of voltage at all times just to make sure that it doesn't move up or down. So in order to test that, we set the position to something out of its range. So this is in meters. So a position of 2 is about right there, so 2/3 of the way up. And then now we can tune our feed forward. So just to give you an example, if I set it to 1, you can see that the position is going up all on its own, and that is not what we want. Basically, what we're doing is we're trying to find the smallest value possible, the largest value possible, that allows us, that doesn't move the motor up, but still keeps its position. So I'll start with 0.1, and what we're looking for is for this bar to stay, the blue line, which is position, to stay flat, and then once it starts creeping up ever so slightly, then that's whenever we know that we need to decrease it. So for now, I'm just going to keep doubling it. So 0.4, 0.8. Oh, 0.8 is too high, so I'm going to set it back to 0. And then now that I've done 0.4 and 0.8, I'm going to do the midpoint between those 2 points. So that would be 0.6. And you can see here 0.6 isn't changing anything. So now we can go between 0.6 and 0.8. And that value is 0.7. 0.7 is too high. You can see it's still going up. What I like to do is, for example, if you see it going up and you need to bring it back down, I just set it to negative. And then I set this back to the last value smallest value that I knew. Sorry about that. Now now that I see that 0.6 is a pretty okay value, I'm gonna slowly increase it until I see this bar moving. You can see the position hasn't updated yet. At 6.62 it does update though, so that's not good. So we want to bring it back down. 0.61 it didn't change. It looks pretty steady at 0.61. Actually, we can see here, if I pause and I go back, you can see this little this little change in the velocity. That might indicate something. So I'm gonna test it again and just see. So 0.6, nothing happens. 0.61, nothing happens. Okay, so that's good. We saw that 0.62 did something. So you can see that it hitched up a little bit and now it's going up. So 0.615 is too much. So it looks like 0.61 is a pretty good value. You can see the position staying pretty stable. This velocity is staying pretty stable. This velocity might be changing simply because of the simulation, because there's no actual gravity, there's no friction. So that could be part of the reason why this is showing up like this. So 0.61 looks like a pretty good kg value. Now what we can do is we can start actually tuning our PID. So the first thing we want to do is tune our p-value. So we can go to 0.1, and then 0.1 looks really slow. And if we go up here, you can see it is really going really slow. So now we can increase it to 0.2. And if we watch it, it's still going up really slow. So we can set it to 0.4. It's still going up really slow. You can see it right there. And then I'm just doubling this every time until I get somewhere that looks nice. See, that still looks pretty slow. And again, this is for my simulation. In your actual mechanism, you might not need to go this high. But basically what I'm doing is I'm just doubling it until I get to something that I like. So 3.2 is still pretty slow. It's reached the position by now. So you can see here that this position graph, if I zoom out a little bit, you can see how it's like slowly tapering off. That's not what we want. We want it to look as rectangular as possible. So basically, if I go up there, you can see that it's still curving at the top. That's not really what we want. We want it to be like a sharp up, a sharp across, and then a sharp down. So we can also watch the mechanism and see how it looks. So if I 12.8 is a pretty big value, but we'll see how it goes. So we can see here, this still looks pretty curved and then it goes flat. So, but you can see the improvement. So here, look at all this. Look at how slow it took here, how slow it took here. It's gotten faster and now it's pretty close to vertical. But again, we can still increase it. So let's go to 25.6. And I'm going to make this small just so that I can see the simulation. And you can see that honestly it's pretty quick. And that might be because of how the simulation is set up. If I go to 51.2, yeah, it might just be because of the gear ratio on the motor is good, and so it's pretty high gear ratio, and so we didn't need to do too much tuning. But now that it's pretty steady, I think also there's a lot of weight on this mechanism, and so that might be part of the reason why our KP value is so high. But that is how we tune our elevators. In the next video, if you watch the arm video, that one is a little bit more finicky, a little bit more realistic in my opinion to how PID tuning might go for you. And so I would watch that video as well in order to get a better example of how to kind of do the whole process rather than this example here, because this one was a pretty simple tuning. We didn't really have to do much. We didn't have to use motion profiles, but the arm mechanism is a little bit more complicated, and so I would watch that video as well to learn more about trapezoidal profiles and how that part of the tuning process works. Okay, thank you for watching and hope to see you in the next one.